In order to explore Mars, we put a rover named Curiosity on the surface, and my job is to help operate it. So Curiosity, you can think of it like a really cool remote-controlled car on another planet. It's a 6-wheeled rover, and it has some instruments that are mounted on the rover's mast. It also has some instruments on the end of the rover's arm, and several instruments that are inside the rover's body. So the way that operations works is we spend a full day on Earth trying to plan what the rover's doing that day on Mars. And at the end of the day, we send up a bundle of commands, and the rover gets them, carries it out overnight, and we come in the next morning with brand new data. So I'm actually really liking some of these rocks on the lower left part of this image. My role in mission operations is that I'm responsible for any of the geology observations that we do that day on Mars. So we're trying to figure out where are we driving next, what are the key science objectives, what targets can we pick that will help us meet those objectives, and what instruments are we going to use to collect the necessary data. In addition to working rover operations, I'm also doing research with all of the data that the rover is sending back. So for example, there were some rocks that we'd seen in the distance, and initially people on the team were suggesting that maybe this was formed by wind or water or volcanic activity, and my claim was that these were formed by water. My team designed a 3-week campaign to fully investigate this exposure of rocks. Some of the data that we were using came from the mast cam, which is a camera that's mounted on the rover's mast, and essentially gives you the view that you would have if you were standing there on the surface. And I also used a camera on the end of the rover's arm, which acts like a geologist's hand lens or a magnifying glass and really gives you some detailed information down to the level of an individual grain. So we collected a lot of really great data, but we were still trying to answer the question of how did these rocks form? Were they formed by wind, water, or volcanic activity? And as it turned out, a lot of the textures that we were seeing were inconsistent with a volcanic origin, so we could rule that out. And then we noticed that some of the grains that we were seeing were too large to be picked up and transported by the wind, so we could rule out that option. And then we found some evidence that was really consistent with rocks being formed by water. So for example, some of the grains were really well-rounded, and they showed evidence for dents in them that represent collisions with other particles as these rocks were picked up and transported by water. So in the end, the claim that these rocks were formed by water was best supported by all of the evidence. So where is Curiosity going next? Well, we're currently driving towards Mount Sharp, which is this giant mountain in the middle of the crater. And it's about 5 kilometers tall, which is huge compared to many of the mountains that we know here. And one of the reasons why we're excited about this is that as we drive up this mountain, we'll be investigating different types of rocks, and we're going to continue to search for evidence for past habitable environments. And it's really exciting because every new place we go on Mars, we learn something new about the planet.